Okay, so today we're going to use the Laplace transforms and inverse Laplace transforms to solve for this second order homogeneous differential equation. We have these initial conditions, which are important, and let us begin. So we're going to be using this table down here. And I chose to use that over this table up here is because, well, it kind of gets messy with this. It's good if you had, let's say, a third order differential equation. But let's just focus on this. And I also wrote up here, in case you forgot what Laplace transform is. I'm not going to be computing the Laplace transforms of functions, but we can do another video if you guys liked me to. So let's start. So we have a y double prime here. I gotta stop doing that. Y double prime is equal to s squared, Laplace of y, minus s y, which is the y original value function, which is 9, minus y prime at 0, which is 64. So let's just do that. We're going to get s squared Laplace of y minus s times 9, which is from there, minus, well, y prime is 64, minus 2, and don't want to forget our brackets, it's 2 times this whole entire Laplace. So we're going to get s Laplace of y minus 9, which comes from a minus here, and then y naught's value. Then we're going to do minus 120 times, well, it's just Laplace of s. Laplace of y. And that equals 0. So now let's try to simplify this and, play around with it and see what we get. So we're going to get s squared Laplace of y minus 9s minus 64 minus 2s Laplace of y plus 18 comes from factoring this number through, minus 120 Laplace transform of y is equal to 0. So let us move all our Laplace y terms. So we have one here, one here, one here to the left side, and all our other terms. So we're going to move these together, and we'll move this one together. And we're going to do that so we can factor out Laplace of y, because we want to solve for it. And you'll see why we want to solve for it in 1 minute. So we're going to get s squared Laplace of y minus 2s Laplace of y minus 120 Laplace of y. And so we got rid of this term, and this term we moved. Now let's move minus 9s. And then we have minus 64 plus 18 minus 4d6. Okay, and that's going to be equal to 0. So now we can factor out all these terms. And then we can add these terms to the other side. So let's do that. We get Laplace of y times s squared minus 2s minus 120 is equal to 9s plus 46. And now let us, we can solve for the Laplace of y is equal to 9s plus 46 over s squared minus 2s minus 120. So let's go look at our Laplace table. So we have our Laplace table right here, Laplace transformations, and we see that, well, there's nothing that really matches our Laplace transform. So let's play around with this function right here, this Laplace transform. And, well, we see that we can factor the bottom. So let's do 9s plus 46 is equal to, let's see, if we do, negative 12 and 10, let's see if that works. S negative 12, s plus 10. And that gives s squared, s plus 10, s minus 12, s 120, and that works. So we're going to get now that our Laplace transform of y is equal to 9s plus 46 over s minus 12 s plus 10. And we're going to see here that this is also nothing on the Laplace transforms table. So let's use partial fractions and split it. So we're going to say that this is equal to a. We can pick either one because this is a variable. S minus 12 plus b s plus 10. Let's times this entire side by the bottom. So that means that if we times this entire thing by s minus 12 s plus 10, we're going to see that we're just going to get this top term is equal to this times this term, and then this times this term. So we're going to get 9s plus 46 is equal to a s plus 10 plus b s minus 12. And we can now use some algebra to get rid of one of these terms. So we see here, if we say s equals minus 10, we're going to get 0. And here we see if we say s equals 12, we will get 0. And then we can solve for the other term. So we're going to do that. We're going to do this. Let's do it. And 9, well, let's do this one first. So we're going to say s equals minus 10. Minus 10 plus 46 is equal to, well, this term goes to 0 now. And we're going to be left with b minus 10 minus 12. And that's going to equal minus 90 plus 46 is equal to minus b times 22. And I just factored out the negative sign. So we're going to get negative 44 is equal to minus 22b. We get that b is equal to 2. Now we can do the same thing for a. So here we're gonna do s equals 12 and solve. So we're gonna get 9 times 12 plus 46 is equal to a 12 plus 10 plus b times 0. We're going to get, that's 18, that's 108 plus 46 is equal to 12 times a plus 10a, which is also equal to 22 times a, which is also equal to, now doing this term, well, we're going to get 114. 114 plus 40 is 154. We're going to get that a equals 154 divided by 22, and that is equal to 7 and 2. And that is from above, where we just plugged in our 7 and 2. And that is also equal to the Laplace transform of y. So we can now look at our tables and let's see if we have anything in common. So right now I'm looking at it and I'm seeing some similarities between this and our value. So if we take the Laplace transform and then here, well, let me factor out a 7. Because I don't see, I see first of all a negative sign and I see a 1 on top. So I factor out a 7 and I times by 1 s minus 12. And I do the same thing for here. I'm going to factor out a 2. 1 over s. I noticed down here that a is related to a negative sign. So I can do a minus 10. And that's the same thing, right? So times a negative 3, I get a positive. So now we're going to get, taking the inverse of Laplace on both sides. So taking the Laplace inverse, of the Laplace is equal to the inverse Laplace of both of these, is 1 s minus 12 plus 2 1 over s minus a minus 10. Oops. And we see we're going to be using this one right here. That 1 minus s to the negative a is going backwards from the Laplace transform to y is going to be e to the at. So we're going to get that what? Let's see. 7 e. So a is 12, as we see here. 12 t. And then we're going to do plus 2. You see a is negative here. E the negative 10t. And that is equal to our y of t. So we just found our solution to a differential equation. But how do we know this works? How can we be sure that this is even a solution to a differential equation? Well, what we're going to do here is, we're going to substitute our y of t in there. So we have a second order differential equation. So we're going to take the derivative twice and substitute each value function into these components. So y of t will go here, y prime of t will go here, and y double prime of t will go here. So let's first, take our derivatives. We'll get y prime is equal to, let's see, that's going to be 14, 84, e to the 12t minus 20 e to the minus 10t. And then we'll get y double prime is equal to the derivative of this. I believe that's 1008 e to the 12t plus 200 e to the minus 10t. And that comes from the chain rule from Calc 1, where you have f of g, and then you take f prime of g times g prime. We're going to do 1008 e to the 12t plus 200 e to the minus 10t. And I'm sorry about this, looks like it's down there, but it's supposed to be up here. Minus 2 times the derivative 84 e 12t minus 20 e to the minus 10t. Then we do the next one, minus 120, big number, times the original function. So 7. And that has to equal 0 for this to be a solution. And you can think of this as like, some advanced algebra. You know what I mean? Okay, so 108 e to the 12t plus 200 e to the minus 10t minus, that's 868 e to the 12t plus 40 e to the minus 10t minus 0.14. There we go. 12t minus 240 e to the minus 10t equals 0. Let's look at where we have 12, 12, 12, and then 10 in our exponent. So let's move those together and see if we get 0. So we're going to factor out e to the minus 10t and put 200, put plus 40, and then minus 240. That looks good to me. That looks good. And then we're going to do plus e to the 12t, 1008, and then minus 168, minus 840. And that has to equal 0. So we know this equals 0 just by looking at it. But this one is not so easy to tell. But we see if we can say 1008 minus 160 minus 84 minus 8. So we know right here that this is going to be 200. So 200 right here, like if you move this 40 over here, you get 200. So 200 minus 800 is minus 1,000. Minus 1,000 minus 8 is minus 1,008, and these cancel out. This whole thing is 0. So we get that. We get e to the minus 10t times 0 plus e to the 12t times 0 equals 0. So this, indeed, is a solution to our differential equation. Right here. We just solved the differential equation using Laplace transforms and taking the inverse. So I hope you guys enjoyed my video. It turned out to be a little longer than I expected, but I hope it was beneficial.